We've been talking about inequations and inequalities. Of course, on a number line, we know how to do that. But once we go into two dimensions, we no longer have just a line. We have regions we now create. So let's have a look at regions in the plane. So how do we approach it? Well, the first thing we need to know is what is the boundary? Much like with the ones we were looking at before, the first thing we did was find critical points. Same idea, it's the boundary. Now, what do we do with the boundary? If it's just less than or greater than, then we use a dotted line because the dotted line on a number plane indicates this is not part of the solution. That's why we dot asymptotes. They're not actually part of the solution. It's just saying, oh, we know it's approaching that. We know it's going there. If it is included, so if it's an equal to as well, then it's a solid line and we know, well, yes, that boundary is included. Now, the point of intersection of two lines. If one of those boundary lines is not included, then the point of intersection is not included. So we should be circling that point to indicate that it's not included. Then, again, just like the other inequalities, we then test the region. Let's see, where are we? Does the inequality work or not? And we know where to shade. So let's do a very simple one to start off with. Y is less than x plus 3. So the first thing we do is we draw in x plus 3. It's dotted. Now, which side are we? Instead of picking a number, we pick two numbers, one for the x, one for the y. I want to make life easy for myself. The origin is not on this line, so let's use it. 0, less than 3, yes or no? So we know we're on the right-hand side of our line there. Of course, we don't have to have lines. X squared plus y squared greater than or equal to in this case. We recognise that to be our circle. So there it is, draw in our circle. We have again broken up the number plane into two regions, inside the circle and outside the circle. Where are we? Let's test 0, 0. 0 is greater than or equal to 9. True or false? False. So we're on the outside of the circle. Well, this one's interesting. Y is less than the square root of 4 minus x squared. Our semicircle, and it's dotted. At this stage, there still is only one section, because if you imagine it, it could sort of spill out and go around the top here and do all that. So there actually are some more boundary lines I have to draw in. Let's test 0, 0 though. 0 less than 2. Yes, it is. So you would think it's just that, but it's not, because as I say, it is also that. It creates a corridor. And you'll notice that these lines are solid, not dotted. Always go back to the original question, because think about it. Below the x-axis, along that line, all the y values are negative. And so it will satisfy that inequation, because a negative number will be less than the square root of 4 minus x squared. So they are solid. But you now have a dotted line joining a solid line, so the point of intersection should be circled. And if you're unsure, again, substitute the point in. Let's use this one, 2, 0. 0 is less than the square root of 4 minus 2 squared. Well, no, it's not. It's actually equal to, it's not less than. So, hence, not included. Y is greater than or equal to x squared, and y is less than or equal to 3x plus 4. We've got two regions here. So let's do it. The first one is our parabola, and it's a solid line. I have broken it up into two parts, because obviously that parabola keeps going. So where am I? Can't use 0, 0, because it's on the boundary itself. So what did I use? 0, 1. Whatever point you pick, you just need to make sure you know where it is. Is it inside or is it outside? So 0, 1. Is 0 less than or equal to 1? Yes, it is. But I don't shade in yet. What I'll do is I'll just draw some crosses or something like that so I know, righto, I'm on the inside of this parabola. Now let's draw the line. Also a solid line. I suppose we should find the point of intersection just to make it complete. So solve them simultaneously and we end up with -1 and 4. So we know those points. So back to testing our inequality. 0 is less than or equal to 4? Yes, it is. So I know I'm on the right-hand side. So I'm looking for the section on the number plane that has both red crosses and blue crosses. Hence, I must be in there. Technically, I should then dot those boundary lines that are not part of that region, because those boundary lines are not part of the solution. If you were to pick a point that's on that line outside of that region, it would not satisfy both of these inequalities. So technically, they should be dotted as well. That's the one.